distance between 2 points, you essentially take the difference between their x coordinates, square that, the difference between their y coordinates, square that, and take the square root of the sum. Does anybody know where the distance formula is derived from? What geometry concept? John? Not slope. Anybody else have a guess? Are you saying that because you see x2 minus x1 and y2 minus y1? That's a good guess. But if I have 2 points, you don't have to do this, just watch. And I have x1, y1. That can be that coordinate. And I want to find the distance between that and another point, x2, y2. I'm essentially looking for how long this piece is, right? Pythagorean theorem, exactly. So if you kind of created a right triangle from that, this side squared plus this side squared would have to equal your distance squared, right? Pythagorean theorem. This length is going to be figured out by taking the difference between your x coordinates. Here's x1, here's x2. So that length is x2 minus x1. So that squared plus your other leg squared, which is going to be y2 minus y1, equals your distance squared, your hypotenuse squared. So a squared plus b squared equals c squared. And if you're solving for d, you're taking the square root of both sides. So d equals, and there it is. Yes? You've probably seen that before. Little refresher. The midpoint formula, you're literally just averaging your x's, averaging your y's. You're getting, if you want the midpoint between two, you're going to kind of go halfway between them as far as their x coordinates are concerned. So you'd be kind of somewhere in this range. And you're going to go halfway in between them as far as their y coordinates are concerned. So somewhere in this range. And once you kind of average both of those, that'll hit your midpoint of your segment. Okay? So average the x coordinates, average the y coordinates, and those are your new. Circles you did do last year. So the standard circle formula is here, where HK is your center and R is your radius. Your general circle formula that you spent a lot of time last year completing the square on that to write it into the standard form of a circle. But your general circle formula is an x squared term, a y squared term. They have to have the same coefficient, by the way. In this case, they're both 1, but they could both be 2 or 3. An x term, a y term, and then just a constant. Just out of curiosity, do you know what the shape, what would happen to your circle if one of these was an x squared, but the other one was a 2y squared? Does anybody know what that would do if they weren't the same? Very good. It's called an ellipse, but yes, it would still be circular in a way, round in a way, but not perfectly round. So it would be pulled or stretched a little more in one direction than the other. Okay? That's like an Algebra 2 chapter that's just kind of not there anymore. So you never learned any of that, but yes. Good. All right, so write the standard form of the equation of a circle with the center at -2, 3. Very straightforward. So x minus -2 would be x plus 2 squared plus y minus 3 squared equals radius squared, which would be 16. I need a Staples easy button. That was easy. Graphing an equation, obviously we need to pull the center from that. Trista, what's the center coordinates? Say it again. Yes. Sorry, I was looking at this one. 2, -4. And your radius, Marissa? 3. So we're just going to graph that, go to your point, your radius 3 up. This is how I do it. I don't know how you do it. I just do 3 up, because 3 to the right, you can count up, down, left, and right on a graph. 3 down, 3 to the left, and then from there I just have to kind of ballpark it. And my scale is way off, because that point would not be out that far. The domain. What is the domain of this circle? Connor? Negative 1 to 5, very good. Interval notation, parentheses, brackets, mixture, brackets, yeah. And the range, Olivia. Negative what? Negative 7 to negative 1. Good. Domain, range. All good. Here's what we did more of last year. So converting, and the way I teach this may differ slightly from the way Mrs. Ziggy teaches it, but they all get you the right answer. So I always say get rid of the constant. So I would add that 23 over. And while I'm doing that, I'm also going to organize this. So my x squares are by my x's. So I'm going to move my 4x up front and move my 23 over. And then I have really an x binomial right now that needs to be completed into a perfect square trinomial, and same thing with a y binomial that has to be completed into a perfect square trinomial. So what is the magic number here that's going to complete this perfect square trinomial? Aiden? 4. And how'd you get that? Right. Yep. So take half of that, which is 2, and square that number, which is 4. So you're going to add a 4 in there on the left side of the equation, but like anything, you can't add something to the left without adding something to the right. And on your y trinomial, what's our magic number, Mackenzie? 9. Half of negative 6 is negative 3. Negative 3 squared is a 9. So add 9, add 9. Because I made those intentionally, I picked the number that was going to make this happen. I intentionally made those perfect squares, meaning a perfect square is something that can be written as blank squared, right? So what is that can be squared to give you that trinomial? Bailey.
X plus 2.
Very good. And how did you know it was x plus 2?
Because like when you take 1/2 of the 4 in the original, you take the positive 2 now.
Right. Yeah, that's like a little shortcut. Good. And on the second trinomial, that factors into what, Nate? Good. And then on the right-hand side, 23 plus 13 is 36. So what we now can gather is that our center is negative 2, 3, and our radius is 6. Okay. Graphing a circle on a calculator. So, have you ever done this before? Have you ever used a calculator to graph a circle? Or do you foresee there being an issue with that? Your calculator only graphs what? What'd you say? Y equals, yes. And circles are not these, by the way. only graphs functions. Very good. Your calculator will only graph functions, and circles are not functions. So there's obviously a little bit of a conversation to be had about how to graph a circle using your calculator. It can be done, but we have to be creative knowing that our calculator only graphs functions. So it does tell you here, yes, you have to solve for y, because in your calculator, and you don't have to get your calculators out, you can just watch me, but in your calculators, your y equals menu is just that. It's y equals, y equals, y equals. So in order to graph anything, you have to solve for y. So I'm not going to solve for y here because I have y's in two locations, one squared, one is not. If I were going to do that, I'd have to go through this process and complete the square on that anyway. So I'm going to solve for this y, which would require what first? What first move, Mitch?
Try to get with 2 squared.
Mm-hmm. Sarah, what would you do next? Okay. And what do I have to remember when I do that? Very good. Plus or minus. And then we add 3. So how do you foresee us addressing the fact that your calculator only graphs functions? How's that kind of been addressed and come up with our solving? Any ideas? Yeah. Right, we have to graph 2 different functions. We're going to graph a positive square root function and then a negative square root function. So individually they'll be functions, together they'll make a circle. So here is what that would look like. Your positive square root of 36 minus parentheses. Then we can get out of those parentheses and add that 3. And then the negative square root function. Get out of those parentheses and add the 3 on that one. So when we graph this, there's the top half of our circle, and there's the bottom half of our circle. And just based on the pixel quality of a calculator, it's not going to really ever bring those together. Even though they do both have the same endpoint, right? Does anyone know what that endpoint is? Take a minute, see if you can figure out what the endpoint is that they both technically would share and come together at, but the calculator doesn't show it, and what the endpoint is over there. Andrew? And how did you figure that out? Right, so he didn't count, although you probably could have. He realized that the center is -2, 3. So the center is at -2. So based on the fact that the radius is 6, he brought that 6 units to the left to get that -8, you said?
Yeah.
And then -2, 6 units to the right is a +4. So, and the y coordinate for both of those is 3. Good? Does that look like a perfect circle to you? Looks like an oval, doesn't it? Did we talk about this yesterday? Yeah, not in the context of a circle, but we talked about it in the context of being reflections over the line y equals x, because you're looking at a rectangular screen that's set up with a square. How would we fix that? Joe? How so? If we were to leave one of them the same and change the other one, which one would we have to change, do you think? This is just creative thinking here. Stretch the y out. So let your y go from, rather than negative 10 to 10, let it go from like negative 12 to 12. Let's test that. Better or worse? Did that get better? More like a circle or less like a circle? Yeah. You actually would want to change the x because you want the ratio of your x scale. See how the x is the longer side of the rectangular screen? So I think you'd change your x maybe to negative 12 to 12 and keep your y the same. And honestly, for it to be perfect, you would have to measure that and keep the ratio of your x to your y the same. We don't have to go that much detail, but just for fun. Abby's having a blast. All right, so we graphed a circle on the calculator. We're good with that. And lastly, just quick distance formula. Using these points, find the distance, find the midpoint. So your distance formula is just going to be the difference between your x coordinates, which is 2 squared, plus the distance between your y coordinates, which is also just a 2 squared. It's going to give you the square root of 8, which reduces to 2 root 2. For the midpoint, average your x's. What's the average between 3 and 5? Why aren't you talking to me? 4. Average between 4 and 6? 5. All done. Before we just have time on the homework, just because you do guys